So there's going to be a series of steps, part 3, I'm sorry, again, of the chromatography, column chromatography video. So there's going to be a series of steps, and that's kind of the bad part about this is you got to make sure that you do these in the correct order. You're not going to get anything to work out. But the order is going to be you're going to run hexane through the column. And if we're looking at the column and we look at the sand layer, and then I'm going to call this the adsorbent here. All right. And then here's my, come down here to my, that's terrible. Let's try that again. Come down here to my frit. The frit will be right here somewhere. So this material will be all the way down in here. So when you have this, here's that sand layer. So if you're looking at your liquid, I'll use red here. That's okay, but you don't want to do that. You want that level to just be right under that level of that sand. When you see the liquid disappear under the sand, stop. And that's why they recommend this to be 1 centimeter. That gives you time to shut the thing off. If it gets down into here, you risk a chance of ruining the whole column. This can never be dry, the green area, ever. So that liquid can only go under that surface. So first you're going to load it with hexane. So when it just disappears this level, then you're going to load your tomato paste. And then very gently, like with an eyedropper. So now you're going to have, so I'm going to call this the tomato paste now, this red. And then you're going to put some solvent. We'll do that in yellow. I'm going to put some solvent over the top of it. Just a little bit to that. And rinse out your beaker with a little bit of the solvent. So then open this up. Let the entire red material get below the surface of the sand, or into the sand, below where you can't see it anymore. Once it's in there, then this column, our columns, I don't even know how to do this. Let's see. Our columns, you might be this full in it. You're going to have all this area up here. Then with the cap on, load this thing up with hexane. And then you can pull the cap back off, and now the thing can drop back down. And then all you have to do is sit there, is watch this thing move down the column, and you continue to replenish your hexane supply. Now, when you see the yellow beta carotene band start to drain out of the column, so let me say this again. When you see the yellow beta carotene band come out of the column, switch to, so we load the paste, run and replenish. Let's do this again. Run and add more solvent. Okay, so then when beta carotene exits, doesn't have to be all of it, not exists, exits, then add the, this time it's 10%. It's a little more polar, acetone in hexane. Okay, and you're just collecting all this stuff in a beaker over here because you really don't care about it. Add more when you need it. Okay, change beaker when red orange band exits. That's what you want. So collect about 5 milliliters of that. from the center of the band. So you can throw out the first part of that. But as that red band is coming out and liquid's starting to add up, you might want to use a small graduated cylinder here. What I would do is I would not take the first part of that band because that's still going to probably have some beta carotene in it. So then I'd get into the middle of it, and be careful there, though. That's why I say put another beaker there, because if you mess up on it and it all goes out before you decided that it's the part you want, you're going to probably still have to go ahead and use that. But from the middle of that red band, you want to try to get 5 milliliters of it. And then very simply, at that point, just let anything else run out of the thing. And at that point in time, you are finished. Now, we have to actually use the spectrophotometer. The spectrophotometer, you have to take, you have to dissolve your band in 10% acetone hexane, more of it. And that dilution, I'll have to get you that. I forget what it is. I think we're going to use like 1 drop for like 10 milliliters. But I'm gonna verify that for you. I apologize. For some reason, I do not have that number here with me. So we'll dissolve the band in that, and then you'll need to run the background, which the background is straight this. And once you've run the background, then you'll run your sample. Collect your sample from, set the machine to go, and I'll get this set up for us, 250 to 600 nanometers. Scan on this thing takes about 2 seconds. So yeah, you may have to wait in line a little bit, but I mean, it's a 2-second thing. We can keep a cuvette of this handy so that every time, but you do have to run this every time before you run a new sample. You can't store your background like we did on the other machine. And then what we're going to do with that is you're going to get a graph, and if everything works perfectly, you'll get a graph that should look something like this. Don't look at the, yeah. If there's no degradation or not a lot of degradation, we'll see this solid graph. With some degradation, you'll see the dotted graph. We start to create, you'll notice a bunch of absorbance in this area. And over here is the 2 peaks we're wanting to look at, because the way we'll calculate this, and this formula is in your book, there's a way to calculate. There's the formula for it. And that formula, what you're going to do is take the smaller height divided by the larger height of the last 2. So what you're going to want to do is draw like a horizontal line across the valley. See if I can make this work. There we go. So this valley right here, you want a horizontal line right there at that valley. I didn't do a very good job. You're going to measure these 2 heights. And you're going to take the smallest one divided by the largest one. So we'll call this A and B. So A over B. And then I think it's minus 0.4. And then divided by 0.4 times 100. But we can look at that thing down there. I'm going to run out of time on this, and I don't want you to have to come back. And that will give you your percentage. There it is. Yeah, exactly what I said. So that will give you your percentage of the material that got degraded, and you can make your judgment there and your conclusion about, does the processing from the plant mess that up. See, it's Thursday.